Welcome all. This is Kieran Patel, working as assistant professor in Computer Science and Engineering Department, BLDSCET, Vijaypura. Now, friends, in our previous videos, we have covered the basic transformations that we can apply on any geometric object, namely the translation, the scaling, the rotation. Now, we shall look into the coding of the rotation function. How can we, translate the concept that we have learned in our previous videos into an OpenGL code? Now, here is this code, right? So basically, first what we do is we have to define a point in a two-dimensional coordinate system, right? So that's why we have taken the class, which you can see, class WCPT2D, that means a point in two-dimensional word coordinate. And we take two values, which is x comma y, in the form of floating. Then let us come to this function here where the actual rotation happens. Right. Now basically, if you have to rotate an object, what are the inputs that you need in order to rotate the object? Basically, what you need is you need the vertices values. You need the vertex, right? So hence it is defined here. Or you can say it is provided here. Then the next thing that you need is the number of vertices that a polygon comprises of. Yes or no? Yes. And hence we have this as n words. That means the number of vertices that a polygon is defined with. Then we have another point, which we call it as a pivot point, or in my previous video I have referred it as the reference points. Right. You also need to know what is the reference point from where this rotation is initiated. Because for an object you can have different reference points from where the object has to rotate, from where the polygon has to rotate, from where the point has to rotate, from where the line has to rotate. And hence we call that point as the pivot point. Nothing but the reference point. Then the most important thing is theta. Theta is what? Theta is nothing but the angle. The angle by which you want to rotate a particular polygon. Even that needs to be provided as an input to the rotate function. And hence that we do it in this case. Alright, once that is done, we define a new variable here or a new object here, that is verts rot. That means the rotated vertex value. Alright, so basically what you do is you take a polygon which comprises of multiple vertices, right? So you apply the rotation, and when the rotation is applied, what changes? The vertex value changes. Right, so once that vertex value changes, that again needs to be recorded in some of the other variable, right? And hence we have taken this verts rot, nothing but the rotated vertex values. Then we put, there is a local variable k, which of course is used for the for loop to loop with some specified condition. So what is the condition here? We start from k is equal to 0, as you can see here, until k is less than the number of vertices, and after every loop what we are going to do is we are going to rotate the value of k. That means we are incrementing the value of k. Right? Now Wordsworth k dot x is equal to pivot pt dot x plus words k dot x minus pivot pt dot x into cos theta minus words k dot y minus pivot point dot y into sine of theta. Now to look at this, it may it may create a confusion in your mind, but it is not that complex actually. We have seen an equation earlier in our slides. Alright, so let me remind you of that equation. This is the equation. X dash is equal to xr plus x minus xr into cos theta minus y yr into sine theta, where x dash is nothing but the words rod, that means the rotated vertex. So no, xr is nothing but the reference point. In this case, it is the pivot point, right? And then x is nothing but the vertex value minus again the pivot value into cos theta minus y is nothing but the again the vertex value, y value of the vertex, and then we have the reference, which is again a pivot point, and then into the sine theta. So exactly this is represented in the form of the equation here. Similarly, we can also find out the y dash. Y dash is equal to xr plus x minus xr into sine theta plus y minus yr into cos theta. So the same equation we could transform it in the form of a code or the equation. And then once we get the rotated values of a particular point, all that we got to do is we got to draw a polygon which is accomplished with this particular function, which is GL begin GL underscore polygon. And using a for loop, we could mention all the changed values of the points that represents the rotated vertex values. By this way, we can rotate a polygon with respect to the reference point, or in this case, we call it as the pivot point. Alright friends, so we shall look into the homogeneous representation of two-dimensional transformation matrices. Right? So for translation it is x dash y dash 1 is equal to 10tx 01ty 001 into the column matrix of x, y, and 1. So basically it is p dash is equal to t with the parameter tx and ty multiplied with the original values of y, xi, y for a particular point. Similarly, for the rotation we have x dash y dash 1, the column matrix of x dash y dash 1 is equal to cos theta minus sine theta 0, sine theta cos theta 0, 0, 0, 1 into again the column matrix x, y, and 1. So basically it means p dash is equal to r, which is defined with the parameter theta, into p, or the product p. So I hope you are all well aware of what is p dash, what is r, and what is p by now. So I don't want to repeat them. Alright. So now we shall look into the two-dimensional scaling matrix, homogeneous matrix representation that we are talking about. it would begin x dash y dash 1 is equal to s6 0 0 0 sy 0 and 0 0 1 multiplied with the column matrix of x, y, and 1. So basically it means p dash is equal to s, which is defined with the parameters sx and sy, into p. Alright friends, I hope you're clear with the concepts of rotation. We have seen that how do we write the uh, the rotation function, or how do we implement the rotation function in the form of OpenGL code. Also, we have seen the homogeneous matrix representation of all the three transformations, that is translation, rotation, and scaling. I hope you have enjoyed the video. Please like this video and keep supporting me. Thank you. Thank you very much. Good night.